Hello, hello, hello. Hi, everyone. Welcome to the Starknet Basecamp 2026. We are hosting a series of sessions about how you will learn on Starknet, create smart contracts and apps. So this is thanks to the support of Starknet Foundation, OpenBuild, and Quantity Labs. This is Jan Alarcon, and I'm going to be the main host for this session. So I'm gonna share my screen now, so you guys will check more details on this. You can see it now. Let me show it in this way. Okay, cool, cool. Looks better now. So yeah, this is Jiang Alarcon. We're gonna start with a base camp, Chinese base camp, where you will learn more about what is Starnet, what you can do with Starnet, and what other blockchains are related to Starnet. Okay. So this is the main thing that we are gonna, at least from the, from the Quantum Tree Labs team. This is both of us, Jean Alarcon, Jing Hao, can call me, and Richard, that is gonna also host the next sessions. Yeah, as we mentioned, this full Basecamp and series of session is hosted by Quantum Tree Labs, OpenBuild, and Starnet Foundation. And also, like, you can check more into this, like, Discord, YouTube channel, and a few more resources that we will provide. And there will also some like optional tasks that you can do after each session. And before we start into, deep dive into Starnet, we want to show you what's the big picture for you guys that want to deep dive more into the technical side. There is a live website about Starnet Academy where you can check more resources about Starnet. There are base camps coming, usually once or twice a year, and this one is for more for Chinese people. There is a Starlinks that is an app where you can practice your Cairo skills, and Speedrun Star where you can practice your how you can build app application on Stark, building some, solving some challenge. And few more, you can connect, you can join to any meetup or any, the ambassador program that they have. Also, regarding to hackathons, there is always a hackathon each 3 or 4 months, and also startup houses where you can come with ideas and also build cool projects. And few more, if everything looks okay, you can go into the next step is where you can apply for a seed grant and get some mentorship on that. You can even scale, go into the next phase where you can, talk with VCs, join to accelerator programs. And later on, you can get even a, a bigger grant. It's like a grow grant from the Starnet Foundation, and few more like programs, like proportional programs where Starnet can sponsor you the gas fees that your apps is, paying. Yeah, this is gonna be a big journey, a long journey. So we have to start from something, and we are starting from this pan, from the base camp. We're gonna, host in total 6 sessions. We are in the number 1, where we will check about Bitcoin, Ethereum, Starnet, and layer 2s. And but as you can see, there will be more about what's the Cairo language, how can we build a smart contract with Cairo, how can we test with FM Foundry or Scaffold Stark, how can you build your front end with the Scaffold, and even you can build mobile apps with this. Okay, we jump now into this part, Bitcoin and Ethereum. So before we want to start into this, you will realize that when you deep dive into the Starnet ecosystem, you will see how it is quite related with Bitcoin and Ethereum. So that's why we want to start explaining a bit more of Ethereum. So starting with this, talking a bit more of history, Bitcoin was like born on 2009. As you can see on this part, it was the first block of Bitcoin was mined on January 3rd. And inside of the message that was built or was minted into this block, there was this title of the newspaper that is matched with the title of the Times newspaper. So basically, it's about the economic crisis that happened during 2028, 29. So that's why Bitcoin was born during this economical crisis. So yeah, they decided to attach this message. Yeah, usually the first block mined into any blockchain is called the Genesis block, and it was created by Satoshi Nakamoto. That is the guy or the girl or any group or someone that created this blockchain. Yeah, he created Bitcoin, but suddenly at 2011 he just stopped it and disappeared and moved it on to someone else. But the community is running the Bitcoin blockchain. If you can track his wallet, actually he owns around 2000, sorry, 22,000 BTC, so quite a lot of money until now. But he never used it. He just his last activity was around this time, so it's just like all of these tokens or coins are just sleeping there. Yeah, as we mentioned, Satoshi Nakamoto is the one that published about Bitcoin on this white paper during 2028, where we explain how we can, use this kind of peer-to-peer electronic cash system. So you can check more into this link. At that time, they use more about like forums where and emails to spread this kind of like news or papers at that time. And it was very active. He was very active on the developing the protocol until 2010, I would say. And this was his last measures later on in 2011. That he mentioned, okay, I move, uh, I have moved on to other things. It is on good hands with Gavin and everyone. So basically, he just gave this project to the community, Gavin and someone else that he decided is, a good person uh, to give access to the Bitcoin protocol. And until now, yeah, nobody know who is Satoshi, but we know about his contribution on Bitcoin so far. So at that time and until now, what is trying to solve Bitcoin? Why it was born? So basically, there was, as I mentioned, this economic crisis around the time 2028. So most of the current currency, like the USD dollar, usually is losing this, is purchasing power of currency. It means like you can buy less and less every year with the same amount of money that you have. So your purchasing power is most of all the currencies. The purchasing power is decreasing, and most of the services and commodities are getting expensive. And one of the main reasons also because usually the central banks they can print money anytime. So at the end, the value of these bills of this money is decreasing because the central bank can print money. And yeah, like I mentioned, yeah, they are the only one responsible for this. So effects, as most of you can realize, that housing affordability crisis, getting if you want to buy a house or an apartment is increasing so fast year by year, and especially because what we mentioned, yeah, is mainly because the value of your money that you can store on USD is decreasing, yeah. Also some like a stock market bubble that happened at that time, and yeah, inflation, yeah, everything is getting expensive. So what is different with Bitcoin if we compare with the US dollar or any other currency is like the system itself is different because in this case, every 10 minutes, there is already a fixed amount of BTC that is, the coin, Bitcoin is created. This new BTC is so everyone that this new BTC is created is usually reward. It's reward for the Bitcoin miners that keep like active or they keep creating new blocks for the Bitcoin blockchain itself. This is not also like a subsidy. Until today, the current reward is around 3 BTC. That is kind of a lot of money, we can say. And every like a 4 years, interesting event is called it like the half. So it is like every 4 years, half of this reward is being like reduced. So after 4 years, the new reward will be 1.6 like that. So it's getting reduced every year, every 4 years. And the next halving, this is the name of the event. The next big event will be on 2028. And the most interesting part of this is that BTC has a maximum supply of 21 million. So until now it's around 19 million, if I'm not mistaken. So the maximum supply of Bitcoin that will circulate ever is just 21 million. So that's very different if we compare with, other like a currency where you can keep printing and printing more, or minting more tokens or, coins. But Bitcoin or BTC is different. That's what we mentioned before, the Bitcoin supply and the subsidy. So as you can see, the Bitcoin supply, since it was born in 2009, it was zero. By, every 4 years, we getting like more Bitcoins, yeah? For example, during the first 4 years, there was around 11 or 10.5 millions of tokens of Bitcoin. And at some point around 2090 or 2100, it will reach the maximum supply. And on this line, you can see the rewards, yeah, or the subsidy, as they call. At this point, the subsidy, as we mentioned, 2026 is around, three. As you can see, five around here is three BTC. But as you can see, it was started with a very high reward, like around 50 BTC. So a bit more here of how is different Bitcoin with the USD dollar. It's like any kind of currency or any kind of central bank of each country can print as much money as they want. But if you are not the central bank, you are just a random guy that want to print, you cannot, because you are violating, you are going against the rules of the law. So that's why there is like a common concept or common terminology called it fiat, that in Latin means let it be done. It's like a fiat money. It's more like, okay, money that can be, created at some point. Scarcity enforced by law, yeah. So scarcity means like how less or how much is, I mean, how easy is for you to get this kind of like money or this kind of token. The more scarcity that there is, the more valuable this token can get. So if it is like, for example, look at the gold you can say is kind of like it's a scarcity good because there is like less gold in the world, and the value is getting more expensive. So in somehow how scarcity is working on Bitcoin? Basically, Bitcoin, as we mentioned, is a protocol and it's following the rules that has been defined into the code. So it means like you cannot print BTC coins, but you can get BTC coin if you solve a challenge. Yeah? So if you are a Bitcoin miner, you will get a reward if you manage to solve the challenge. So around every 10 minutes, a new BTC is minted. And if you manage to solve the challenge, you will get this amount. But you cannot trick the system, yeah? You cannot somehow try to cheat and say, okay, I will get 100 BTC. Because the system itself will realize that someone is doing some bad actions, and they will kick you out, or they will say, okay, this version where you minted 100 BTC is not the valid one. It's like incorrect, or it's like a parallel, system. So we are not going to keep working on this, and we will keep working on the real one. So that's why there are, many validators or nodes that they will realize that someone is cheating. So they just, kick him out, in the sense like he lives on his own world, but the real one will be, this one where everyone reach a consensus. What is the real status of Bitcoin? And what's the real reward for each miner? So now talking a bit more of proof of work, because that's one of the main mechanisms that is working on BTC. So basically, like we mentioned before, miners need to solve a challenge. And this challenge is basically a number. They have to provide a number that is going to match, you know, uh, with what the protocol has defined. In this case, for example, this is just a basic example. The Bitcoin protocol will ask you give me a number between 0 and this huge number, and the Bitcoin miner need to start giving numbers. If it doesn't guess the correct number, is I cannot mine the Bitcoin. But if it gets the right number, okay, he will get rewarded. And usually, year by year, it's like this number is, or this challenge is getting more difficult. In order to keep this like a 10 minutes range between new block. So at some point, okay, this range of number can go from 0 to the t. So the miners can, spend less time trying to solve this challenge. But at some point, the protocol will fix or update to increase this range of number. And then the miner will need to, do more computation and spend more time on this. They do this in order, to keep this 10 minutes on like average rate. So we will talk more about how Bitcoins is working in this case, or how Bitcoin track your wallet and your wallet balance. So internally, the Bitcoin itself gonna manage a database, and this database is gonna store the information of unspent transactions. So it's called it like a UTXO, unspent transactions. And this is how it's gonna, keep or read the balance of each individual or user. For example, we have this guy called Daniel, and he has a balance of 10 BTC. So inside the Bitcoin UTXO database, we can find this, this like a kind of ticket or UTXO, where it shows, okay, Daniel has one UTXO and the value is 10 BTC. It's like a traditional wallets, or traditional like the real world wallets. You have a wallet and you have many like coins or like bills there. So the logic is kind of similar. So now we have this second user, is Jerome. So this second user, as we mentioned, is in this case he will have 3 UTXO, 1, 2, 3. And each UTXO has different value. Yeah? The value of this one is 2 BTC, the value of the second one is 5, and the value of this one is 0.5. So at the end, the balance of Jerome is 7.5, but internally on the database, it has like 3 tickets. We can say ticket, just like analogy, 3 UTXO. So because we explaining this because it's a bit different how, for example, Ethereum or other blockchains works right now. So what happens when I send BTC? Okay, for example, we're gonna show this part. If it is Daniel again, so if he want to send the BTC, he has to, create a message like, okay, I want to send 1 BTC to Maria, and he have to provide a signature, and the protocol will need to check this. Yeah. So before, first of all, the protocol will check if, okay, this guy Daniel has the funds that he claims to have. The signature, the signature is legit. If it is okay, the protocol or the Bitcoin blockchain protocol will execute, this transaction. So what's gonna happen if Daniel has 10 BTC, is gonna his current ticket is gonna get split, into 1 BTC that he's gonna give to Maria, and then the remaining one will just be like 8.9 for Daniel. And the previous UTXO has been destroyed, we can say, has been destroyed or has been split into 2. Or we can say into 3, because actually there is like a small amount that we have to pay, like to the miners or to the one that's gonna execute this transaction. So here we are using like we're paying a transaction fee for the miners, and then the Daniel will keep us, this amount, 8.9 and 1 BTC to Maria. So next one, this is a next topic that includes a digital signature that is used for almost every blockchain is using this way. And it's quite related to electrical, cryptography and all of this kind of like mathematics part. So basically, on this like a cryptography area, every individual, each one can get a private key, and from this private key you can derive or get public key. So if you want to, to go from your private key to your public key, it's easy. Just apply a function and you will get this public key. But if you want to go from your public key, you want to guess what is your private key, is almost impossible. Cannot do it. Cannot do it right now because classical computer cannot do it. But based on research, they say it's possible if with a quantum computer, you can derive your the private key from a public key if you're using this kind of like a signatures. So why is important this private key? Because you will use this to sign a message. So you will have a message, then you will need your private key to sign it, and then you will get this signed message, And then after that, the protocol can check it, yeah? Okay, this signed message, they will check your signed message with your public key, yeah? That anyone can have, you can share, anyone can have your public key. And they will check, okay, actually this message has been signed from Daniel, because we did here some internal checks that this message only can be signed if Daniel have the private key. This is, like a high level way how it's working. So how do you prove that you created this transaction? For example, again, yeah, Daniel want to send one BTC to Maria. So again, so on this transaction, we have to set up the message, yeah? Send one BTC from Daniel to Maria. And then the protocol will check it, yeah, that actually this message has been signed with the private key of Daniel. And then later can double check, okay, that with the protocol can use the public key of Daniel to double check that that this signature is correct. So he has verified, okay, and then the protocol can approve this transaction. Can you be hacked? Yes. For example, if someone has their own private key and try to impersonate you, the protocol will say no. This signature doesn't match with Daniel public key, because why? Because this private key is different, yeah? Because this guy he's using his own private key, so cannot the protocol will realize this and will reject this transaction. But what if your private key get leaked or someone else like steal your private key? Of course, they can use your private key to send a message and the protocol will accept it. So again, so why is Bitcoin a blockchain? So we're going into the next concept now of Bitcoin. So basically, as most of the blockchains, the block will have two main parts: the header and the body. The body will have internally many transactions that happens in the blockchain. Inside the body, there is also these famous coin-based transactions where it will attach the information about the transaction fee and the block reward. And on the header, the block will show what is the solution of this proof of work, like a challenge that they need to solve. The coin-based wallet, it means what is the wallet that this reward will be sent, and other information. Yeah. So this block, as we say, is gonna be mined by the miner, and then after 10 minutes, another new block will be mined. It will have it will include or will have the hash of the previous block. So the information on the previous block will be, like stored or linked here into the next block in a format of a hash. So that's why we call it like a blockchain, because every block is linked together each other with a hash or with the information of the previous block. And the same is going to happen after that. Yeah, a new more blockchain is gonna, sorry, a new more block is gonna be mined. We will attach again the block hash of the previous block. So as we mentioned before, since the first block that is gonna be mined in one blockchain is gonna call the Genesis block. And for the Bitcoin, the one who did this was Satoshi, the first one that mined the first block in Bitcoin. So we want to check again about proof of work. That is the mechanism how to how Bitcoins work. So we have two actors here: the Bitcoin protocol, that is the system, the code that is running, and the Bitcoin miner that he want to do what? He want to mine a block, and he will gonna ask you what is the challenge that he need to solve in order to mine this block. So in this case, we're gonna provide more details. So what he has to do is like the hash of the header of your block should be less than X. So here we are providing a bit more specific way how it's gonna be, what is the kind of computation that these miners need to do. So we have to provide a hash, yeah, of the header of job block. So here, yeah, and this part is they are gonna do some internal calculation, computation, and it's gonna output a hash. So that's why he's asking for this, for this hash of this data, yeah, the coin with Coinbase wallet, hash, and more. And then how is it calculated? As we mentioned, that this block header need to pass through a hash function that in this case is called SHA 256. So internally it has to pass two times. One time you pass this block header, you will get a hash. You will have to do one more time and you will get a new hash. And this is what we call the block hash. And then since you need to guess, the protocol will double check and say, no, it is not the output that I'm expecting. So you need to keep iterating there until you can, guess what is it. So if the block header doesn't change, the hash will be always the same. Yeah, because the same input will give you always the same output there. So it's always need to be chained there. So how can you chain the block hash? That's where we add this like a nonce. So at least the block header nonce in Bitcoin is where we add this kind of randomness. So here you need to add some random number that in Bitcoin is called it like a block header nonce. So we have this 0, okay, and when we do all this hash, the protocol can say, no, it's not this one. And you can guess maybe one, but no. And maybe if you guess like this number, 500 something, and you do the hash, okay, uh, the protocol will approve because it matched with what they are expecting. So this nodes is gonna, bring this randomness into the Bitcoin protocol. And also big difference that the meaning of nodes here is different than the meaning of nodes on Ethereum, yeah? That in Ethereum is more like a counter, but in in Bitcoin it's just a random number. So again, remember on the header, before we mentioned that is the Coinbase wallet and the root hash, but now we know that we also need to provide the nodes and the previous block hash. And usually, most of this data is fixed already, but except the nodes. And then, yeah, the next block will also, provide this information, but with the nodes, with a new random number, and with this previous block hash, that is going to be the hash of this header. And it will go on like this. Yeah, this is the block n plus 1, n plus 2. So yeah, that's basically on Ethereum, sorry, on Bitcoin. We just did a introduction to Bitcoin so you guys know what's going on there. Of course, later you can research more and yeah, study a bit more of this. Okay, we're moving into Ethereum. That is the second, another, big protocol. It was the main founder or the one of the team members that work on Ethereum is Vitalik Buterin. That's he started working there. Okay, he was born in Russia, but later moved on to Canada, and then he started on Bitcoin blockchain on 2011 because he was the one that founded this Bitcoin magazine. And yeah, because he was deep dive into Bitcoin, he realized that Bitcoin has some limitations. Yeah, at the time until now, yeah. So if you want to, make some updates on Bitcoin, it's very difficult because you will need to require to do a hard fork that is basically, a new blockchain with previous data of the Bitcoin blockchains. And it will need, many things, many components on the blockchain need to get updated in order to, to don't mess around with this. So it's very difficult to do that, and it will take, a lot of time, and maybe not everyone in the Bitcoin community want to do that. That's why he decided to work on his own project, and that's where you can, working on a blockchain that can be easy, to build programs or create programs on top of this. But you don't need to do any kind of like a hard fork or soft fork. That also soft fork implies you need to update something on the protocol level. Yeah. So at that time it's supposed to be like a work computer where you can programs can execute the computation there on Ethereum. Yeah, that's how it was born, Ethereum. So like we mentioned before, the difference with the Bitcoin is like Bitcoin has some programs, some few programs, but they are inside in the protocol level. Yeah, it's like a very low level. So if you want to change something here in the program, the Bitcoin community they have to approve for a soft fork. But yeah, like we say, not almost everyone will agree. It will take some time to implement it. But if you want to create programs on Ethereum, it's easy. You just use Ethereum to deploy your program, but you can be the one that can design what your program can do. So you are now doing like working into the next level, yeah, into the application layer. You don't need to work into the protocol level. So that's very good because it's easy for developers or anyone to to create apps and work on Ethereum now. And yeah, the language that we use on Ethereum is Solidity. There is other language like Viper or Stylus are also getting more popular. But the main one is still Solidity, where you can compile and deploy this like a high-level language into low-level language. The low-level language that Bitcoin is gonna read is the EVM bytecode. That is something very similar, to machine code. But for developers like you guys, you just need to learn a bit more of Solidity, and you can just deploy into Ethereum. But yeah, also for example, on this part of Bitcoin, Bitcoin also handle the Bitcoin script that is also a low-level language. That is kind of difficult, to program on, this kind of language. So yeah, as you may know, as I mentioned, we have Solidity, Viper, and Cairo. Cairo is the language that we will use for Starnet and for these upcoming sessions. And low-level language, we have Bitcoin, EVM bytecode, and the Cairo assembly. Yeah, that can be something similar to the EVM bytecode. Yeah, the idea with Ethereum is like, okay, we need to work in a shared work computer where user or developers, need to execute programs in this like shared work computer. You need to pay to use this, yes. It will depends on the kind of complexity of the computation that you're gonna do, because your program will execute, some steps there. So you need to the longest that your function is on your program, the more gas it will cost. But actually, what is gonna cost the most is gonna be the storage, because storage is very limited here on the EVM. Because for computation, you can execute one time and then that's it, or two times and then that's it. But later, if for storage is something that need to be, permanent there, so it's a bit more expensive if we compare with, complexity of computation. So in order, to use this work computer, we need to use something called like a gas. So the gas is like a home. So this kind of computation or amount is going to be measured with gas, and this gas has a price here that is can be $1, $2, or right now on Ethereum it's like 0.5 or 0.2. It's very cheap, we can say, if we compare with the previous years. So it's gonna be also the value of this gas is gonna depend of the demand of the work computer. It means like if there are many users using this work computer or Ethereum at the same time, the gas is gonna increase. But the less user that use this, the gas is gonna be, low. Like we mentioned, the more demand, the more dollar that you need to pay for gas and per transaction. This is something about gas. And now we're gonna move into the next topic. It's about the halting problem. We're talking about more about this guy, this Alan Turing, very famous, mathematician, computer scientist guy. So we have this concept that a Turing complete programming language support loops, this while or for loops, and this TC language is prone to fail into infinite loops because sometimes it's easy to create infinite loops that can break the system. And these infinite loops can be used in order, to make DOS attacks. So someone can create a program and deploy it with the infinite loop. So it's gonna be attacking your system because it's gonna use and consume all your resources. Yeah, that's why before, the guys that have been working on Bitcoin decided, to take this some measure. So they create Bitcoin script as a no TC programming language on purpose in order to avoid these infinite loops. It makes the language safer, but it's less useful, yeah, because it's very like first it's low level, and second you don't have this like a loops in the programming language. And some examples that TC language, they are more like a high level language, like a Solidity and few others. But we mentioned that the infinite loops can cause blockchain to halt, yeah, to stop suddenly. And Solidity is a TC language, yeah? So that's why that Ethereum was one of the first blockchain that decided to use like a gas, introduce this concept of gas to mitigate this risk. Yeah, because if you create an infinite loop, it will run until the gas that you have decided to pay in order to this program or function to be executed. So as we mentioned before, each low level operation Ethereum has a cost in gas. Every like step of a function or something that you are doing on Ethereum has been mapped how much gas is gonna cost. So gas is a measure of resource utilization. The more resources you're using on Ethereum, the more gas that you need to pay. So as we mentioned, a complex transaction will use more gas than the simple one. Usually, yeah, most of the transaction will define what's the gas limit. You need to define what's the gas limit for your execution. If this execution exceeds the limit, the transaction is not executed, it's aborted. And also in the protocol level, yeah, it defines like a maximum of gas per transaction or per block. So that's why sometimes you need to optimize your code in order, to don't use more gas than it's expected. It doesn't prevent infinite loops because anyone can still, deploy a smart contract with infinite loops, but it prevents at least the DOS attack. Every smart contract blockchain uses gas. Yeah, yeah. Okay, next one. We have these Merkle patricial trees that I will leave you to guys. I will leave this you to guys to check more what's going on, what data is stored in the on Ethereum. So you can check more of it there. And we're gonna jump into this one, into consensus. So basically, Ethereum itself, has been divided into a few layers inside. Two of the most important are this consensus layer and execution layer. So basically, the execution layer is the component that is gonna execute transaction, handle the global state of the blockchain, and there are some clients. Yeah, the clients that implement this execution, layer is like the gates. It's one famous team. One famous team is the Paradigm team is working on the gate. So sorry, on the red. Git is like a Go implementation of Ethereum. Also, we have like a Nethermind that is working on his own execution layer and Besu and a few more other Ethereum clients. And on the consensus clients, we have these different tasks, that they have to do. They have to check who is working on there, or how is the proof of stake working on there. Also need to track that chain head. There is another like clients for this one. call it Prism, Lighthouse, Teku, and a few more. Yeah, and also, the consensus layer is tracking this Bitcoin chain that is, another chain internal on Ethereum that help, to run Ethereum itself. Okay, we move into proof of stake. So basically, this is gonna be the mechanism that Ethereum is using. We will see how different it is with proof of work. In order for you to participate into the consensus and mining a new block or creating a new block, proposing a new block on Ethereum, you need first to install your node and then to stake or send this 32 ETH to a deposit contract. Yeah, that is a contract, handled by Ethereum. So you need to deposit this amount of ETH, and if you get approved, you can participate and join into this like proof of stake system. And basically, you will get, some reward because you will be the one that is gonna create blocks and attest blocks. And of course, if you're trying to do, trying to cheat into the system, your node will go offline. You can lose, the amount of stake that you have deposited into this contract. And also, since you have deposit here, you will get like an annual yield of 3 or 4%. So again, we're about to end this first part. So if we compare again Bitcoin with Ethereum, with Bitcoin, you just basically can transfer Bitcoin from one user to another user, just move money here and there. With Ethereum, you also can transfer Ether tokens, but you can also, build programs on top of Ethereum. The second big difference is the consensus. Bitcoin is going to use proof of work and Ethereum proof of stake. With Bitcoin, you cannot program that much. It's very difficult, and with Ethereum, it's kind of easy to, build programs. Okay, now in this second part, talk about Starnet and layer 2s. First of all, we need to know more about Starnet and history. For example, this part, we can see now Starward is basically the company that has been working on the CK Stark and Starnet blockchains during his early years. So Starward is the profit company that has been doing mainly the research and development. And Starnet Foundation was, born years later as a no-profit organization that is mainly focusing on ecosystem growth of the Starnet blockchain. As we mentioned before, the main issue with Bitcoin is, it's not easy to make programs, but with Ethereum we can. They use different consensus, proof of work and proof of stake. Bitcoin is stateless in the sense that it's gonna, check the balance based on the UTXO database. And Ethereum is stateful, but you can just check dynamic balances there. Storage, they use the database on Merkle trees, and for Ethereum they use like Merkle Patricia trees. Yeah, usage, energy usage, because you need to mine the Bitcoin. Usually, you will at this point you will need like a kind of data center to block to mine a new block. But the proof of stake on Ethereum make this energy usage low. So scaling Ethereum, basically at some point Ethereum got, congested. There was like too much demand on Ethereum. At the beginning there was not that much demand, but later it's getting, more popular. And especially there was one event called CryptoKitty event that, during those days and week, the transaction fee was very, very high because there was, kind of like a FOMO, and many people wanted to get more familiar with these NFTs at the time. And just because of this event, this was like consuming 50% of the resources of Ethereum. So it was like, okay, there was too much demand and you need to pay a lot for just to execute one transaction. Later on, during 2021, there was a second like big demand on the Ethereum, also related to NFTs. And at some point, a transaction may cost 100 USD. It doesn't make sense. So Ethereum got congested and not usable at that time. So that's why you need to scale and, that were researching and looking for ways to scale it. And there were a few ways to scale. This is the original network where you have like a nodes that doing, like some computation. One way to scale is, okay, that these nodes, the requirement to run these nodes need to increase so they can, handle more computation. So it means you also will need to have less nodes, but more powerful, yeah. With this, reduce the decentralization. It's going to become less reliable and, less secure at some point. But some blockchains like Solana, they use it this way, but Ethereum don't want it to, they decided to don't go to the way. That's why they decide to keep Ethereum as layer one as it is. But on top of this, there might be some other blockchain also that can, uh, handle and process hundreds of transactions per second, and then can use Ethereum as, security layer. That's why we have all of these like layer tools, like Arbitrum, Optimism, CK-Sync, and Starnet, that basically they have the sequencer that will handle most of the off-chain computation, and then, use Ethereum as a security layer. We have optimistic and zero knowledge. Optimistic basically will use, a fraud proof, and zero knowledge will use decay proof, or that we will check more on this. And layer 2s can be directly EVM compatible or very similar to EVM compatible, or can be a different ecosystem, yeah, like Cairo VM in this case, that is for Starnet, that is not EVM compatible, but still uses the Ethereum layer one as security layer. So what is the pros that layer twos in general that is high performance because the transaction fee is very very cheap and is like it's using the Ethereum's security part. And the bad thing is like they are kind of centralized. They are not like a group of nodes that are running. It's just like usually they are just a single sequencer or a few nodes that are only being managed for a single entity. So there is no centralization, and it make the ecosystem more fragmented. It's like if you want to use Arbitrum blockchain, you will need to get like Ethereum, Ether on the Arbitrum blockchain. If you want to use Optimism, you also will need to get Ether on the Arbitrum, on the Optimism blockchain. So at the end, you will end up with many, many different tokens just to, to interact with all of these chains. This is the second concept about block space and block space. So basically, Ethereum will have these two spaces to store data. Block space permanent, and block space is, will just last for 30 days. And the good thing is like a layer two can make use of both of these. On this part of the block space, they can send the proof in the on this part of the block space. They can send some like another data that is useful, but it's not crucial as the one that they need to send to the block space. Block space that's permanent. So yeah, it's gonna be more efficient because the layer twos, the sequencer will need to spend less money because they just will need to pay for the main amount of money for the block space, and they can send a lot of information here, but with just like a cent, very cheap, because this blob space is not interacting directly with the EVM. So it's not interacting directly, so it's not doing any computation, and it's not being stored on the blockchain. Yeah, so it's good. So it was introduced in 2024, and usually every year there is more upgrades on Ethereum that they have been improving more this blob space. Until now, they got around 14 blobs per block. And usually, there are like third parties, companies, or teams that they are interested on this blob space and they can store on their own later. So this is how Ethereum managed to scale. They somehow redesign their architecture, improve their architecture in order for layer twos to make use of this. before we mentioned about optimistic and CK rollups, as we mentioned, like if you want to check more on this, optimistic, basically you have some assumption. So we need to say that the sequencer assume that it's gonna be honest until proven otherwise. It means like it will optimistic rollups will assume that everything is going okay when they send data to Ethereum, unless someone prove that something that the rollup sent is wrong. That's it. You just will assume that everything is okay until someone proves that you are not, there is something wrong with you. But it's different with CK rollups because the sequencer honesty is verified on regular basis. It's more like based on maths and cryptography. We can see that we can verify what does if the sequencer is doing something honest or not. So for security, yeah, like I say, the optimistic rollups they send fraud proof that is kind of complex, and this is like a big deal. And secure rollups or validity rollups they send a validity proof. This is more like a it's simpler. Finality it means like layer one finality. It means like if you want to bridge from an optimistic rollup to Ethereum mainnet, it's gonna take around 1 week to get your assets there on Ethereum mainnet. But if you use a CK rollup, it's just gonna take around few hours because just gonna check some, because it's based on cryptography and mathematics. There is not like a period of challenge like this one. Block space, yeah, in the block space, as we mentioned, we're gonna send most of the important information, like state routes, layer one, layer two messages, block commitments. For optimistic rollup, they're gonna send float proof, similar for CK rollup, but they will send validity proof instead. Blob space, they're gonna send like we mentioned, like extra information that is relevant but not very important in the long term. That's why the blob space will store this like some it's going to store a list of transaction details because remember that rollups they are like a batch. They're going to batch many transactions into one. So for this one, they will send all of this list of transactions. But for CK rollups, they just need to to send a state diffs. It means like how is the state, how the state has been changed from this transaction compared with the next transaction. So the amount of it's like the size is smaller. Verifiable computation. This is a famous example that usually most of the Starnet guys use it all the time. So what's the thing? It's like okay, you have your team that want to execute a program. Yeah, and in this case, the example is like okay, you have a program that like you want to launch, you want to launch a rocket into Mars, let's say, and you need to compute, you need to know how to save fuel, what is the best launch window, what is the best trajectory, and a few more, things. Then you will need to create algorithm, a program to solve these problems. But the thing is, like, you will need a very, huge and big and super computer in order to execute this program. That's why you need to rely on a third party that can be one like a rival country that has these resources. So okay, you need to rely, maybe like we have this example like maybe China and USA or a few other countries that they are rival, but at the same time they need to cooperate. So okay, so what's going to happen that your team that is in your country need to rely into your rival country machine. So you will send your script, your program, to get executed into this supercomputer, and they will send you the result. Okay, that's good. But how do you know if the supercomputer, has malfunctioning or they are trying to sabotage and send you a wrong result? You don't know, you just need to, rely on them. That's why there is like Cairo, that is a probable language where you can, create your script, your algorithm, and when this program is executed, you will get the result, but at the same time, you can get the proof. And what you can do is like, okay, with this proof, with this proof, uh, usually you can, verify on your side that this result is okay. So the executing this proof is going to be cheaper than, executing this full program. That's why it's, important, this kind of language. So you can see if the execution is intentionally modified or something happened. This proof will be show a result that is invalid here. That this result is invalid because the proof is not is not passing. So a regular computer is able to keep a supercomputer honest. It means like a small computer can verify this proof, and with this they can say that the result that has been sent from this rival country is okay, it's good. That's what is Cairo. So it's a probable language that can enables verifiable computation. It's run on top of the Cairo VM. So Cairo VM will execute and check the syntax of this language. It's similar to Rust. It has this ownership model. If you are familiar with Rust, you can see it. And it's used like some trace, macros, strongly typed. Can be used outside of Starknet as normal programs, but usually we use them to build smart contracts. And you don't need to know anything about CK or provable, how to verify and prove all of this. This is all under the hood. Validity proof. So this is the next topic. In this case, we're talking again about scaling layer one. So in this case, the block producer is gonna be, for example, as someone that is gonna produce a block, and they will say, okay, the new state is 42. Just choosing a random number. So if someone is gonna produce this a new block with this new state, then all the validators, all the other nodes need to also double check that this guy is doing something correct, and they also should get this new state. That's why the computation to produce and validate the block is the same, yeah, on the layer one or on Ethereum. It's the same because you can see it's the same size. But on Starknet it's a bit different on the Starknet blockchain. Okay, besides, so you also with the nodes and the one that is producing the blocks is gonna say, okay, this is the new block, this is the new state, but this guy also will send a proof, yeah. And then at the end, the validators, they don't need to execute all of these, all of this task or all of this computation. What they need to do is to, okay, get the proof and verify if this proof is correct or not. And with this, you can save ton of extra computation, as you can see, because the size is smaller, yeah, than the executing itself. So, but how is it exactly? So usually the sequencer has to execute all of these transactions. But if you want to validate the proof, it's just, a log of 2. It's a base 2. So if you can see in a graphic, so to execute the transaction, it's going to be like, this line, just like X line. But later on, when you start increasing, the complexity or the amount of data that you want to execute or verify, for the verification, is going to go into this like log function. So as you can see, you can start saving a lot of computation on this way. So basic example is like, imagine you have a file, yeah, and then you use like a zip, yeah, a zip in order to compress this file. So similar logic we can use for computation and validity proof. So validity proof will help you to compress all of this computation. So what are validity proof? They are like, yeah, a use case of zero knowledge proof. So we need to convince the verifier that the verifier is going to be, in this case of Starknet Ethereum, the verifier is going to be a contract on layer one on Ethereum, no? That is gonna check the proof that Starknet is sending to this. So we need to convince the verifier on layer one of a new layer two, like Starknet, layer two state without sharing transaction details. Yeah, we don't need to send all the transaction details. We just need to send the proof, and then the verifier will double check on his side, and then will update the state on on Ethereum. Since we are not sharing the transaction details, it doesn't mean the transactions on layer 2 are private, because at some point you still can track the transactions, because it's like a open, ledger, open, transparent blockchain. So there is no privacy anywhere there. It does make verification efficient because it's very short time. Yeah? Validity proof, validity rollup. Yeah, at the end, yeah, because we can call it Starnet a validity rollup. It's based on Starks, like we say, it's a use case of zero knowledge proof. But what kind of zero knowledge proof? They use like Starks on Starnet, and not a Snark that is also well famous on the CK community and blockchain. Efficient proving and verification. That's what you can get with validity proof. Second big question is why Cairo VM and not EVM? Remember that the Starnet is using the Cairo virtual machine and it has its own ecosystem and is not compatible with EVM. So it means you cannot use, like MetaMask wallet directly as you can use, for example, with Arbitrum and Ethereum, or with Arbitrum and Optimism and Ethereum. For Starnet, you need to use their own wallets, and the way that you interact on an app in Starnet is different. That you need to interact with Ethereum. To deploy an app on Arbitrum, you just need to use Solidity, same as Ethereum blockchain. But for Starnet, you need to use a different programming language as Cairo, so you cannot use Solidity to build on Cairo. That's why we mean, okay, our Cairo VM or Starnet has its own ecosystem. And why not use CK EVM like Scroll or CK Sync? Because based on the nature of the CK on all of this validity proof itself, they use something like private fields and something more related to cryptography that is gonna perform much better on a different VM than Ethereum itself, because Ethereum itself has not been designed thinking on CK or any of these like new ideas. That's why like for Cairo VM they prefer performance, but they lose in order to sacrifice a compatibility. As we talk about finality, usually Ethereum is getting fast every 6 minutes. If you can rest assured that nothing can get revert on Ethereum. For optimistic rollups, remember, if you want to bridge your tokens from optimistic rollup to layer 1 as Ethereum, you would need to wait like a 1 week or a bit less. But for Starnet, you just need to wait around 5 hours or less. And there is a new state in Starnet called pre-conf, where after half of the second, you can also assume on layer 2 that your transactions cannot get reversed. So it's very fast, and it can improve your UX UI experience on Starnet. Okay, why Starnet? Because it's optimized for CK technology. You can do a lot of computation paying very low gas fees. It's secured by CK Starks or Starks proof. And Ethereum is very powerful as a language. It's live on mainnet already 4 or 5 years. It has around 8 trillion of USD there, and you can withdraw your asset easily. And there is no trusted setup. That is something, if you check more on CK Snarks, you can see that CK Snark has a big weakness, that is trusted setup. Smart wallets, this is something very important on Starnet, because this is how it's different from Ethereum, in the sense that Ethereum we have this EOI. It's like how every new wallet is created. It's like a EOI. But in Starnet, every wallet is a smart contract. So you need to deploy it and start interacting with this. And the good thing of this is like it allows you to have more new features. For example, this one here. You can easily use like a Touch ID or Face ID integrate. If you are like a wallet provider on Starnet, you can implement these features and execute multiple operations in a single transaction. Yeah, that's why we can, this one is a very good metrics and improve a lot into on the UX UI of your application. And as I mentioned, every wallet is a smart wallet or a smart contract, and is using something called account abstraction. we're gonna check more on these complex interactions. Sometimes your action requires multiple steps, especially if you are more familiar into DeFi. You know that when you want to interact with DeFi apps, you usually need to approve, approve, approve a transaction and later, transfer some, amount of tokens to that DeFi protocol. So for that, usually you need to do two transactions. But what may happen is like this one. Let's see. And most of the times you cannot have this. Maybe this step one is your approval that you did, and the second one is your transfer. But this can be the case, or maybe this can be not. Yeah? Maybe there is some another, like a transaction in the middle of these two steps. Your approval is here, but your transfer is here. Or maybe your approval is here in this block and your transfer transaction is on a second block. It may happen on the EVM because in the EVM or the Ethereum, every transaction is one step or one action, as we can say. It is easily, to get attacked, especially with MEV bots, that they can extract some, um, financial information from you, and they can make that your second step, lose some money because they did some previous action before. It happens already, or there are already many few cases. There are a lot of cases of MEV attacks. But what happened on Starnet is a multi-call. So basically, you can use multiple. You can do multiple user operation in a single transaction. So in this step one, you can do approve. You can approve a transaction, and in the second one, you can do like a transfer itself. So it's called like a bundle. You have two steps into only one. And on the block, it's all gonna be always like this. This is your transaction on Starnet, but internally it has two steps. Step one to approve and step two to transfer, execute the transfer. We cannot have these cases like MEV attack because the nature itself of the Starnet doesn't allow to get these kind of attacks. Talking again about account abstraction, it's like a thanks token abstraction. When you create a new wallet, you can have two components: the signer and the account itself. So the signer can be, can live on any device. The signer can be any device that can sign this transaction. Can be your smartphone, can be your computer, can be anything, any kind of hardware. Identify users with a private key, and the account is gonna, it's gonna be deployed on the Starnet blockchain. It's gonna hold your assets there. It's gonna verify your signatures and more. So this is very important because it's different than Ethereum. So in this part, like I mentioned, for example, you have the signer component here. That's like a hardware, like a wallet, mobile phone with your private key. Your wallet, this is going to be your wallet. Your wallet has been deployed on the Starnet blockchain, and this account contract. That's how you call it. And this account contract need to follow this like Starnet implementation proposal SMP, improvement proposal. So it need to follow this like trace and this function. So it's gonna we can use it, or any wallet provider need to follow this. Okay, if they follow this, all good. And then at the end, this smart contract, your wallet can interact with any other contract, can interact with any other user, any other account contract, any other DeFi protocol, any other DeFi smart contract. So at the end, the user that will use his mobile phone will invoke a transaction from his phone, and then it will be checked on the smart contract, and then the smart contract will send some funds to these target contracts. It's good because you can do many things. You can have this multi-sig signer easily. You can have, like, as we mentioned, like a ledger or hardware signer, social recovery. You can use email to recover your account, and session keys, a few more. Currently support many different like, signatures, elliptical, like a star-friendly. This one not except K1, and this another one also. This that we're going more into the graphic part. This is something interesting that you guys can check more. How your smartphone can be used as like a hardware wallet. What's going on? Especially because they use this secure enclave. There is some like a dedicated processor and memory for this, like where you can sign messages on this part because they allow, this kind of signature there. on this like a hardware signer. You can check more on this on your site. It's very useful. So at the end, a smart wallet will give you what? A better UX than normal wallets. You can do multi-call, social recovery, and a few more. As we mentioned this, the next thing that you can do is create your own wallet. You can use Bravos and play around with this. In order to get more familiar with Starnet, ideally you have to install a wallet and start playing around. You can install Bravos. You can follow this link. It's a mobile app, and then play around this, activate the 2FA, install it on your computer, import the seed phrase, in order to see how it looks like to interact with the app. Okay, this is the last section about Bitcoin integration. So while we're talking about Bitcoin at the beginning and Ethereum, because Starnet is looking for this like dual settlement. So on the roadmap of Starnet, they will become the first CK rollup to settle on Ethereum and Bitcoin. So as today, Starnet, what is doing is just sending a validity proof to Ethereum, yeah? And there is a trustless bridge between Starnet and Ethereum. But later on, they also want to expand and also work together with Bitcoin. So at the same time, they send proof to Ethereum, they will send proof to Bitcoin, and they also will need to to create this bridge between Starnet and Bitcoin. So this is the whole roadmap they have. Why they want to do this? Because I believe it's important, to have this trustless bridge between BTC, Bitcoin, and Starnet. It can, create more cheaper and faster transactions. BTC transactions on layer two, so you can have this, kind of Bitcoin layer two somehow. It can be used like as right now the protocol that is scaling Bitcoin is Lightning Network, so Starnet can be, an alternative of Lightning Network. And then we have this BTC5 promote more, DeFi on Bitcoin blockchain. And there are a lot of assets and a lot of volume on Bitcoin that but if it's if Bitcoin become more programmable, build application that support Bitcoin itself can bring more capital efficient to this kind of DeFi protocols. And at the end, you will use Bitcoin also as security layer and keeping Ethereum at the same time. How this may happen? There are few researchers that they are doing. For example, BitBM. This one of the ways that they plan to do it. You can check more on that. Collider BM is also one of the ways. But the one that I like the most is up up upcut because it's easier, we can say, in the sense that you just need to verify on chain and will use this native script logic of Bitcoin. But it will require a soft fork because the Bitcoin protocol need to approve or need to do a soft fork in order to enable this OPCAT, and few more other like opcodes to be updated or enable it into the Bitcoin protocol. But this is still under, debating. But anyway, they are looking for many ways to make this happen. But yeah, what is this OPCAT? Like we said, it's like basically gonna concatenate two values on the stack. And this looks simple, but it's gonna make easier a lot of all of this like execution or all of this like scaling of Ethereum using Starnet. So it can fit a Stark proof in one use case. Bitcoin script able to verify Stark proof. Yeah, at some point OPCAT was working already on Bitcoin, but was disabled in 2010 because at the end it's gonna it may bring this DOS attack, so they decided to remove it from there. As we mentioned, it's still under discussion if they plan to do this soft fork and enable this OPCAT. So one of the two ways, as we mentioned, is a BitVM and Collider VM that still under still under research and development. Okay, this is the end. More like a bit of what is Bitcoin, what is Ethereum, and what is the relationship between Bitcoin and Ethereum. So next topic, we will talk more about Cairo and how to build, smart contracts and what is Cairo also itself. Okay, thank you.